Over to you.
Okay. Hi everyone. Great opportunity for me to share what we're doing at Rolls-Royce for mainly doing the modeling language agnostic at MDENet. And my name is Molly, and I'm mainly working on the control system side of the Rolls-Royce. So for what we do, hopefully people won't think about the Rolls-Royce cars on the switch. That's what we do. I wish so, because we normally can have the employee discount, but affordability will be but it feels so good you have some discount, although you can't buy that. So actually what we do, we make aircraft engines, and also we make the power systems. So, and our sector mainly looking after the MBSE across the whole business in Rolls-Royce to defining MBSE matter model, MBSE modeling standard, and also the tooling automation capability for that. Right. So outline of today. So I'm mainly trying to introducing the overview of our approach, modeling side, and then the challenge we face, why we reaching that solution. And that gives you some more detail, a little taste of each detail of that, and then the agile engineering practice we do. The second part will be the tooling agnostic we're doing using the Epsilon transformation. Yup, University and Rolls-Royce collaborate together to develop that one. So more details about that, what we can do, and also the future stuff we're doing for the reusability of the MDSE models. So the overview of Rolls-Royce MDSE. So we came from maybe around the decade of maybe around 5 to 10 years ago. We all come to this way. So in each project, we define specific modeling standard and also specific modeling tool for that. Some part they're using SysML, some part they're using Acadia, and we find it so difficult to align them together, and also for the reusability. Tooling support is another issue there. Then currently ecosystem, that's our sector. We're trying to align our audit bots to provide like centralized support and also consultancy on that. We find it so difficult, especially also reviewing those the designs is difficult as well. So we trying to propose a universal matter model or modeling language for that. So it just express what the key concept there. And then we're using like MDA approach. So in each deployment of projects, we're thinking about what language or modeling we use. We make the extension on that modeling language to express the same concepts. The main reason why we define our own like matter model or our own modeling language rather than using SysML or Acadia, because the context is different. That's the first issue. SysML is general language, it's rich, but it's not really specifically, efficiently fit our purpose. Second is it's not broad enough to include the safety side. I know SysML 2.0 are thinking about the reliability of safety stuff, but currently we already doing is like safety, like FHA. So that will be functional hazard analysis, FTA, fault tree analysis within our model and also within our modeling language. And also we do for Mika, we do lots of safety side, and also we're doing verification side, system verification stuff, the same model. So the richness is the second point. We're making our own language. So I think some issue we find, that's the reality of the most large scale organization. It's not only us, we're developing our own domain specific or project specific modeling standard or modeling language, because several reasons. Domain or context is different. Even sometimes we have political difference as well, because some people making that decision, they think, I just like that tool, or I just like that language. It do happens, and also the tool set sometimes drive that one as well. They will think about, oh, we want to reuse some of the legacy projects for this rather than we're building from scratch, but they will inherit the tool set as well. Since you're using that tool, for example, PDC Modeler or like Cameo, they are SysML based. So you can't say, oh, I got preference for the Acadia. It's been restricted by that way. And then the other problem, once we're providing cross-project support, we find this two language doesn't support, it is not compatible to each other. and the concept or the richness is different as well. And when we define this top level one, which we will face several issues as well, you can easily define a very general idea that is not practical. It's too general, you can't expect anything. Or too complex, it's too detailed, or too large, the model is too large. And also you will introducing additional learning curve as well. So on tooling side, we will talk more about how we're building the additional learning curve. So that's just one part, very small chunk of our matter model for the universal modeling method. And that part is defined based on our engineering stage. For example, this stage, we just start to analyzing our stakeholder requirements. So what we include there is use case, we're including some functional requirements, we're including parameters for that functional requirements, and also the data exchange in between. The same thing for the performance, we will do some performance analysis, parametrics in there, and also we will do some safety stuff there as well, and also some design constraints flow down. So that's one part of that. In order to define those concepts, we did lean management stuff or lean management experience on that stuff as well. So when we define each concept, we're using a formal method to see the coupling issues, whether that concept covered by another concept as well, to reducing the number of elements we define there. Because what we have experienced by doing this way, we simplified or reduced over maybe 5,000 to 7,000 of modeling elements. Thinking about each modeling element, how much effort your engineer to design that one. So we achieved a lot of reductions or optimization on that. And also we're using this one to define a modeling standard. So that will reduce the auditing efforts. Because, for example, thinking about our auditors, they need to review against your design because they got their checklist. For multiple projects, the learning curve is inherited by them because they need to learn project by project. But if we use this one, the universal one, and give a guidance for deployment of this one, so the auditor will just check box. They will say, okay, I want to check use case. Oh, that's been implemented to certain projects. We got guidance to show the maps, so they're just auditing several things or several attributes of that concept. So reducing some of the learning curve, and for the specific deployment of certain projects, this diagram shows how you deploy, because this one is the deployment on the PDC integrity, the kitchen in there. Prompt name will be PDC integrity modeler, which is a SysML-based tool, but we made lots of extension for capturing our information on that. So like use case, we stereotyped additional copy persistent use case, and we put in the DPA status, which is our design technical assurance status. So we say post that stage of review, we sign off that document. So that shows you how you deploy your universal concepts to each project. And we will provide a user guide for engineers. We develop our wiki page shared across that projects. So we'll let them know, okay, how, because in here it just tells you what rather than how, and also some engineering process behind that. So that will be all captured in our wiki page. So it tells you, in order to define this one, how you can click through that tool, and what does it mean, and also in which engineering process you need to define this one, and what is the best practice of that is all captured there. Right, and also we got some tooling specific profile defined in here as well, because we've got different tooling structure that needs additional information from the model. So in between those, I'll show you later on the tooling slides, you will see we actually, that will be defined as intermediate format to transform models between different modeling language. And also the transformation, or how you map your concept between different languages, captured and also shared in our wiki page. So we find that useful because what the learning curve has been reduced a lot because some experienced engineer from project A, they're familiar with system now, and they know that concept they need to do, but we sometimes move them to other projects for agile management and also for meeting several deadlines as well. So once we move them, the learning curve previously is an issue, but gradually we show them the macro rules so they can easily understand, okay, in order to create stakeholder in SysML, I now may move to the Arcadia-based one. That's the concept I need to create there. So it makes them who's more comfortable to adopt the agile management or agile engineering. Yeah. The second part I want to show there is, yes, from the methodology part, that looks great, but in reality, when we're implementing this one, we face lots of problems. So in order to reduce the rejections, because engineers is our customers as well, you can think about that way. You tell them, okay, in order to reduce your work, I introduce another language that you to learn. They will say, definitely not. I hate that. So we hide it as much as possible for them. So what we tell them is, you use your current tool, no matter which font you use. Okay, nothing changed. Don't worry. For example, and then what the transformation have done is we defined a backend tool to automate that transformation for you. The main purpose is not only helping them to understand. The other purpose is we find certain projects define the design can be reusable for other projects as well, rather than building from scratch. Currently, previously we had lots of contractors to do that work because you think, oh, we don't need that much engineering experience. Oh, transforming that. But sorry, I'll make it quick. In order to achieve that transformation, we use the Absolute. It's an open source tool York University developed. It's very powerful. It got all the interface connected to other front-end models too as well. So what you need to define is just understand your domain and understand the modeling, the transformation rule, the macro rule. What we can provide through this backend is, previously, we need to generate this kind of automation capability for each project individually. That takes lots of effort. Like we have a team 2 years just to develop like 100 automation tools for one project. We need to spot 3 or in future more. So we got that centralized. So once they transform into our backend using the universal manner model, they can do just one development for document generation, they can do the traceability, they can do model checking. That model checking not only checking against the semantics, syntax semantics, and they also do some automated engineering level checking as well. And we can do the control management and also requirement management through Escape through Rackif. And also we can do the simulation through transformation. So your system design in SysML can translate into Simulink. So you can do your simulation there. Sorry, run out of time. So I'll quickly tell you why XMI doesn't work, because we tried that one.
It's been badly defined, that's why.
And
differently implemented.
Yeah, 200 is implemented differently as well. I'll quickly show you what does it mean for our side, the backend. The backend will be seamlessly shown as the context menu for your frontend tool. So that's our implementation, and that's one of the backend transform that's EMS based. So you can even visualize what they transform there. And we can do the model checks, so it tells you how you failed against our internal modeling standard, how your model fails that. So we can do self-training on there as well. And we can export the results for the manager to review the housiness of your entire model. And we can automatically generate the document, so we can send out, exchange to our stakeholders, or internally exchange to different parties for that. So it's then the Rackif, we can generate Rackif for doors and also for Polaris, which is another open source requirement management tool. And also we can transform our requirements into Simulink. So software side, they can link in their local tool. Great traceability. That shows one diagram. The top level is the R design the PDC modeler, one of the SysML modeling tools. We created the active design plan, and this is the Acadia tool called Capella. So we right-click the button and transform the majority of that flow into this one. So no additional information lost. The control flow is lost there. Is we deliberately do that. So we got some options to figure out what you want to transform. And we're also enabling some configuration management also, if we show through this way. Like the PDC modeler is a client and server based tool. So so you can't do your configurations unless you do it really hard way. So they can allow you version your model, but it takes lots of memory space for that one as well. It's current, but we can, through the transformation, we can make it file based. So you can configure that in the Git, so you can identify your changes. The software development stuff, because each project we develop right now is not only for that project. We're developing our system product line as well. So you can click the button, generate from the library for your reusable design from Maxi. That will be achieved through the transformation as well. So each front end keep doing the project stuff, and then we will have the product line team to review your design and think about whether that was to bring it up to the library. If they decided yes, we will transform to our backend, it becomes the library. And when new customer requirements comes in, rather than to design from scratch, we're just matching, saying, okay, that stakeholder requirement actually can be fulfilled by the Laxis stakeholder requirement, and also all the enemies designs from there. So click the button, you can generate the system from the Laxis designs. If you've got any variations, you can at the top in your deployment. Right. Sorry, it's really quick, but if there is any details you want to discuss with me, slides is online. I'm really happy to discuss more about that. Yeah.
Thank you very much.